So finding missing sides of triangles. You will be able to find the measure of the side of a right triangle using trigonometry. So first, let's remember SOHCAHTOA. Remember what goes with what. So we know that if we're using SOHCAHTOA, it means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA means tangent is opposite over adjacent. And then you just have to remember which ones are the reciprocals of those. So remember, cotangent is pretty easy because it says the word tangent in it. So cotangent is the reciprocal of tangent. The other two, on the other hand, are a little bit more tricky. Remember that we have 4 of them that start, 2 of them start with a C and 2 of them start with an S, right? So we have to have an S and a C paired together, and those are going to be the reciprocals. So what is cosine's reciprocal? Is it secant or cosecant? It's secant because it has to go with an S. So the secant is the reciprocal of the cosine, which means the cosecant is the reciprocal of the sine. So those are the things you need to remember. When we're doing trigonometry, the angle always goes inside of the trig function, but we never use the right angle, just so you guys are aware. Okay? So when you're ready and you have that stuff written down as just a reminder of what that all means, you can flip to the next page and we'll talk about how to even use our trig function. Yeah. Just put it on my desk, please. When you're done. Oh, wait, we're going to review all of this again, and then we'll do that. But before we do that, has anybody found the sine, cosine, and tangent on their calculators already? They're pretty. Yeah. They're easy to see, right? They're not hidden. They're actual buttons, unlike sometimes how they're like above a button and stuff. Yeah. So it's the one that says SIN, which is sine, COS, which is cosine, and TAN, do you need a calculator? Which is tangent. So just as a reminder, the ratios are going to depend on what angle we are referring to. So in this case here, the sine of A is saying our reference angle is A. So if we're referencing angle A, the opposite leg to A is BC. And the hypotenuse is still AB. So the sine of A is different than the sine of B when you're referencing angle B, because angle B has an opposite leg of AC over AB. Do you guys see how it depends on which angle you're looking at? So it's important you know which angle is your reference angle before you start writing which one is the opposite and which one is the hypotenuse and which one is the adjacent. The cosine is adjacent over hypotenuse. So if you're referencing angle A, next to angle A, this angle here, this side here, AC, is next to angle A over the hypotenuse AB. But if we're referencing angle B, the one that's next to it is BC. So that changes the cosine's ratio because we're referencing a different angle. What you'll notice is that the angle goes inside of the trig function. It's all one piece. The ratio has to do with the sides, what it's equal to. Okay, again, tangent is the opposite over adjacent. So opposite angle A is BC. Next to angle A is AC. So that's why it's BC over AC. What you'll notice is that this is flipped or a reciprocal if you're looking at angle B, because opposite of B is actually AC and next to it is BC. So are we all good with those trig functions? Is anybody confused how those get set up? Okay, so let's learn how to put this into our calculator. So this says, use your calculator to estimate each of the following. Round all answers to the 10,000th place. So you have the tenths, hundredths, thousands, 10,000ths. So that's 4 decimal places. All you have to do when you type this into your calculator is hit the button sign, type the number 61 in and hit enter and round it to 4 decimal places. We need to make sure none of your calculators are in radians, so make sure we're all getting the same answer. If you don't get an answer that I'm writing on the board, then your calculator is in radians and you need to let me know so I can change it. So we get 0.8746 is our answer. That is the ratio of the sides. So if you did not get that number, please let me know. You did not? You might be in readings. Okay, the rest of you keep going and I'll call on some of you. Desiree, what did you get for the tangent of 33? 0.6494. Wrong room.
Sorry.
Across the hall. You're fine. I was like, I don't know who this is. Did 6494? Lindsay, what did you get for the cosine of 117.2?
Negative 0.4570.
4570? Does it round up to 1?
Maybe I didn't.
Okay, guys, why is this one negative? You don't have to write this down. This is not something you need to know for this class. But what this is talking about is it's talking about what is known as the unit circle. The unit circle is 360 degrees, right? Because a circle is 360 degrees. Well, every quadrant goes by 90 degrees. So these angle measures for the first two are in the first quadrant. You know that, you don't know this, but ordered pairs are cosine comma sine, okay? Well, you know here that this is positive, and this is negative, right? So the ratio of the sides here is going to be a positive over a positive, which is going to make a positive. And 61 and 33 are between 0 and 90, all right? But 117.2 is between 90 and 180. So it's going to be somewhere over here, which means our ratio is going to be a negative and a positive, and that's going to make a negative. So that's why that's a negative. Not that that's something you need to know until later on. You'll learn more about this stuff later, but I just wanted you guys to understand why some things are going to be positive and some things are going to be negative. You don't have to worry about that's not something you need to know. All right. I just wanted to let you guys know why some of them are positive and some of them are negative. Yes, you do. Yes, you do. You don't have to, I want you guys to know where things come from. You need to understand that. No, you're going to get another lesson because I'm really nice to you because I need to get you guys caught up. All right. So set up the correct trigonomic ratio, then use the ratio to find the missing side x. If necessary, round your answer to the nearest tenth, which is 1 decimal place. Okay, what is the angle measure that I know? What is the angle measure that I know here, Harmony, in that first one, in number 4? What is the marked angle? Oh, we never use the 90-degree angle. We never use the 90-degree angle, so I'm kind of glad you said that because it allowed me to point that out. So 24 is our reference angle here. So opposite of the 24 is what, Casey? 19. The hypotenuse of this triangle is what, Morgan? Which means that my other side here is my adjacent. So what I'm going to do is I'm going to write SOHCAHTOA underneath this. And I'm going to have to figure out which part of SOHCAHTOA I am going to have to use. So I'm going to use little check marks here. So do I have something on my opposite side? Yes. Do I have something on my hypotenuse? Good. Do I have anything on my adjacent? No. But I do have something on my hypotenuse, right? Do I have anything on my opposite side? Yep. I don't have anything on my adjacent. Which one of these trig functions can we use to be able to figure this out then? Based on those check marks. So, which is sine, right? Because we know two pieces of information here, we don't have enough, we have enough information to find x. Otherwise, we have multiple unknowns, and that's not going to help us. So you see how the two check marks here let us know that this is going to be sine? So we're going to set up our trig function, and you always put the angle on the inside, so it's sine of 24 equals opposite over hypotenuse. So the angle goes here. This is the opposite, and that's the hypotenuse. And I wrote hypotenuse instead of x. Sorry, guys. So now, the first thing you're going to do whenever you're solving for a side is multiply by the denominator. It doesn't matter if it's an x or if it's a number. So we're going to have to multiply both sides by the denominator. In this case, what is our denominator? So we'll multiply both sides by x. And I need you guys to understand that sine of 24 is one piece. So sine of 24 is one piece, which means you cannot separate it. So that's why I'm putting this little box around it. Now, is x by itself yet? How could we move sine of 24 if sine of 24 and x are being multiplied? What's the inverse of multiplication? Division. So you're going to divide by sine of 24 on both sides. So now you have it so that x is by itself. So you're going to do 19 over sine of 24 in your calculators. So go ahead and do 19 divided by sine of 24 in your calculators and tell me what x is to the one decimal place, to the tenths. Ian, did you get what sine of 19 over 24, sine of 24 is? Yeah. What was it?
46.71.
So it would just be 46 point, because we can just do the tenths, yep. So our side length would be 46.7. So let's think about this. We are finding the hypotenuse. The hypotenuse needs to be the longest side, right? Does it make sense that it's bigger than 19 then? Do you guys see that? So logic through things. Does that make sense? Because if you get a hypotenuse that's smaller than one of the legs, then you did something wrong, because that shouldn't happen. All right? So that's the first one. Let's look at the next one. What is my reference angle in this one here, Jill?
31.
So we're referencing 31 degrees in this one. What side is my opposite side in this one here? Olivia, what side is the opposite side in this one here? The one that is unmarked. Very good. Carmichael, which side is my hypotenuse?
The one is 34.
So that makes my last one here the adjacent side. So I'm going to write out SOHCAHTOA. And I'm going to use my check marks. Do I know the opposite? Do I have any markings on my opposite?
No.
Nope. Do I have anything on my hypotenuse?
Yeah.
Do I have anything on my adjacent?
Oh, X.
X, so that is a marking. Do I have anything on my hypotenuse? We don't on my opposite, but I do on my adjacent. So in this case, what am I going to be using, Devin? Sine, cosine, or tangent? Cosine, because it is the two checks. So we do cosine of the angle equals the adjacent over the hypotenuse. So again, this is the angle inside of the trig function. This is my adjacent, and that's my hypotenuse. Logan, what did I say I always multiply by first? So what's in my denominator this time?
34.
So in this case here, so here the x's cancel out, these are going to cancel out. We have 34 times cosine of 31 equals x. Is x isolated already? Is x already isolated, or do we have to keep doing work? It's already isolated, so go ahead and type in 34 times the cosine of 31 into your calculators. Gabe, tell me what you get when you're done with that round to 1 decimal place. So does it make sense that the adjacent side is smaller than the hypotenuse? Yeah, because the hypotenuse should be the longest
What did I do?
side.
Oh, I put the wrong thing. That's why I did wrong.
Okay, what is my reference angle in this one here, Iku? Good, so it's this angle here. So what is my opposite side, Cameron?
6.6.
And Emma, what is my hypotenuse? X. Which forces the unmarked side to be my adjacent. So we're going to look and see what that means we need to use by writing out SOHCAHTOA. Do I know my opposite? Is there a marking on my opposite? How about on my hypotenuse? Not on my adjacent, but on my hypotenuse. On my opposite, but not on my adjacent. So in this case here, Hunter, which one should I be using? We're going to do sine. And we always put what inside of the trig function?
Thanks for the reminder.
Yeah. I just wanted to let you know. Okay. So what always goes inside of the sine function? The angle measure. So we're going to do sine of 17 equals the opposite over the hypotenuse. So that's 6.6 over x. So Morgan, what do I have to multiply by first in this one? We multiply by that denominator first. So we have x times the sine of 17 equals 6.6. Abby, are we ready to put this into our calculator yet? Yeah, we can't do it until x is isolated, so you're correct. We have to divide by sine of 17. Okay, go ahead and do 6.6 divided by sine of 17 in your calculator. Before you get the answer, though, should the number be bigger or smaller than 6.6 if we're finding the hypotenuse? Bigger, so make sure you're getting that bigger number there. Carmichael, tell me what you get once you get it. And it is bigger, so we're good there. Okay, we have one more slide, and then I'm going to give you the angle one. The other, nope.
We have 2.
Then we're going to have 2 worksheets.
Yeah, but I'm going to give you like only like evens or odds on both to like make it so that it's more like one worksheet. But I don't want to kill you guys. That's not my goal. All right, find all the missing sides of the triangle below. If necessary, round your answer to the nearest tenth. So we're finding all of the missing sides. Once we know 2 sides, what can we use if it's a right triangle? Yeah, so we just need to find one of the sides using trig, and then we can use the Pythagorean theorem. So we're using B as our reference angle here. So I'm going to label my opposite first. And what is my opposite in this case here, Austin? What is my hypotenuse? And you're going to have to use letters, guys. What is my hypotenuse, Ian? And then what that forces this one to be the adjacent. Now, notice we don't have markings on those 2 lengths, right? Could we make a marking and call one of those x without an issue? Yeah, so do we want to find the adjacent? Let's do the adjacent one because we haven't done tangent yet, so that will force it to be tangent. Okay, so we're going to label the adjacent one x, and then we can do the Pythagorean theorem after we find that. So I've already alluded, I just repeat it, I've already alluded that we're going to be using the tangent. That's because we know the opposite, the adjacent, which means that we have to use the tangent. just based on what we're trying to find. So there's two ways you could do this. You could find one of the sides using trig and then use the Pythagorean theorem. Or you could find both sides using trig and using two different trig functions. It does not matter how you want to do it. So I'm going to start with this. So it's the tangent of 62. Hayden, what does it equal? What does the tangent of 62 equal? Perfect. So Daniel, when I go to solve this, what do I multiply by first? Jill, now what? It doesn't matter if this side is bigger or smaller. The legs just have to be smaller than the hypotenuse. Okay, so Morgan, get that in your calculator and tell me what you find x to be. So we're just going to say 12, right? Because that rounds it that way. So we now know that this side is 12 miles, I guess, because it's in miles. And the other one is 22.6 miles. So again, you could always use the trig function first, or we could just substitute it into the Pythagorean theorem. So we have a squared plus b squared equals c squared. So I have 12 squared plus 22.6 squared equals c squared. Thank you, Iku. Just leave that on there for a second. Since this started with decimals, your final answer is allowed to have decimals. Do you understand that? Since this started with decimals, it's allowed to have decimals in your final answer.
What's the other way to do it besides the...
I'll show you. I can do it off here. Okay, that's fine. I'll show. No, that's fine. So what's the square root of 654.76 to one decimal place? 45.6? 25.6, sorry. Yeah. Versus, you could just do a trig function again. So if I wanted to name this one, I'm going to choose a different color here, 1 second. So if I wanted to name this one y, do you see that?
Just do the same thing, but with the y.
So, yeah, so now I know the opposite and the hypotenuse.
So you just...
So I would do the sine in this case. So I would do sine of 62 is equal to 22.6 over y. And I called it y instead of x because I've already used x. It could have been a, it could have been b, it doesn't really matter. So I'll multiply by y on both sides. And then I'll divide by sine of 62. So go ahead and do 22.6 divided by sine of 62 in your calculator. And what did you get? 25.6. So do you see that it doesn't matter? Yeah. So if you hate the Pythagorean theorem and you're really enjoying trig right now, go ahead and do that. If you love the Pythagorean theorem and prefer that, you see that there's two different ways of doing it. Okay? All right, lesson number 1.